safe spaces for bold thinking. Organized under the joint aegis of the Department of Mathematics and the Research Cell, this academic dialogue is an integral part of our broader initiative to reimagine mathematics education in India, especially in the light of evolving learner needs, pedagogical shifts, and the NEP 2020 vision. Why do so many students experience anxiety or hesitation when engaging with mathematics? Why is risk-taking, a skill so essential for innovation and problem solving, often missing from our classrooms? How can we, as educators, create emotionally secure and intellectually vibrant environments where students are not afraid to think differently or make mistakes? This panel discussion attempts to address these very questions and more. It is grounded in 5 core research inquiries that guide this discourse, including what is the role of emotional safety in facilitating mathematical creativity? How can educators identify and nurture risk-taking behavior among students? What gender-based and psychological factors influence students' willingness to take academic risks? At what developmental stage can such behavior be encouraged effectively? What specific methodologies, tools, and classroom interventions foster bold thinking in mathematics? Our aim is to move beyond mere curriculum delivery and explore how mindsets are shaped, confidence is built, and students are empowered to take ownership in their learning. Today's distinguished panel brings together seasoned educators, researchers, and visionaries who will help us unpack the deeper layers of this topic from theory to practice. Let us collectively reflect, question, and co-create a new language of teaching mathematics, one that is driven not by fear of failure, but by the joy of exploration. It is my deepest honor and pleasure in introducing our eminent speakers and panelists to the national level panel discussion amongst the august gathering. To begin with, we have with us Professor Hridayakant Diwanji. Professor Hridayakant Diwanji, currently associated with Setu Initiatives, Udaipur, is a visionary educator who began his career as a physicist, but soon dedicated himself to making school education more child-centered and concept-driven. A founding member of Ekalavya Foundation, former senior advisor to Azim Premji University, and a long-time contributor to NCERT and multiple state governments, he has played a transformative role in shaping teacher education, curriculum development, and textbook reforms across India. Our next panelist is Professor V. Sudhakar Venukapalli ji. Professor V. Sudhakar ji, Chair Professor of Education at Chanakya University, Bangalore, brings a rare combination of expertise in physics, psychology, philosophy, and education. He has held key academic leadership roles at IFLU, Usmania University, and Wipro's Mission 10X, a recipient of several national honors. He currently serves on the NCTE and ICPR as a Government of India nominee. His insights into psycholinguistics, psychoanalysis, and teacher development add a rich multidisciplinary dimension to this forum. I take this pleasure in introducing our third panelist, Mr. K.V. Railuji. K.V. Railuji is a retired faculty member from the government IASE who concluded his official career in 2018. Even after retirement, his passion for education continued as a guest faculty at GIASE, Masiptang, Hyderabad. With a lifetime spent nurturing teacher education, his perspective brings practical insight and grounded wisdom to today's discussion. It is my pleasure to introduce our fourth panelist, Dr. Kandala Ramaya ji. Dr. Ramaya ji, a deeply respected mathematics educator with 26 years of rich experience, currently serves as a school assistant at ZPHS Abapur, Telangana. With a PhD in psychology, Sir is a national mentor for NCTE, resource person for NCERT, and a co-author of several textbooks for SEERT and TOS. His accolades include the National Best Teacher Award 2022 by the Ministry of Education. His blend of grassroots practice and academic depth make his voice especially valuable today. With this very brief introduction of our eminent resource persons, let us now begin the panel discussion. I warmly invite our first esteemed panelist, Professor Hridayakant Diwanji, to share his thoughts. Welcome, sir, to this national panel discussion. Over to you, sir.
Yeah, can you hear me, Santosh?
Yes, sir.
Okay.
Yeah.
Okay. Thank you for this opportunity, because this topic is extremely important, and I will start by looking at the question from the perspective of his classroom. And before that, if we look at what does risk mean, and I think it's important to think about that, because when we say emotionally secure environment for risk, we need to place it in the context of mathematics and the classroom, because there are behaviors which you don't want people to do, and you say that we should avoid risk-taking behavior. We should also avoid reckless behavior. Now, the question is that in the context of mathematics, why are we saying that there is a need to promote risk-taking? And in fact, why is it even important to promote recklessness? And I think it has to do with the idea of what we mean by mathematics and what we mean by learning of mathematics. And I think that is something which we don't normally think about when we start making the curriculum and teaching the curriculum. So if we look at classroom teaching in most environments, what you see is the effort to make children reach the answer to a given problem. And in doing that, we want to give children the method, the procedure, and the steps to be followed. And we like the child to follow that procedure. Right from the beginning, when we start teaching in class 1 and 2, we start with the system of helping the child learn how the writing system by giving the child the advice that write in columns, and you label them as units and tens and hundreds. You write in columns, and then you use this principle of adding and then carrying over, or when you're subtracting, use the principle of borrowing. As you go on, the entire process of primary mathematics is built around teaching children these algorithms. And the students are encouraged to practice these algorithms, to memorize these algorithms, and in a sense, be confident of using them. When we come to fraction numbers, we spend a lot of time talking about how to make a shape into parts and color numbers. So we keep doing that practice of showing 3 by 5, 2 by 5, 4 by 5. And in terms of when we come to operation on fractions, there is no conversation around what do you mean by adding fractions. There is no conversation around what do you mean by adding numbers, or subtraction, and what are the different ways you can think of doing this. And you are simply told that when you have I'm sorry, I'll try to be, it's my net, so if my voice is breaking, I apologize. So when you do fraction numbers, you simply start by saying that if you have to add fraction numbers, take the LCM, do some hanky-panky, and get some numbers on the top and write that, and you'll get the answer. Similarly for subtraction. So the point in the whole exercise is that somehow the child gets the method to solve a problem. And if he can't get the method, you provide him shortcuts. And in all mathematics classrooms, you have these shortcuts which the teachers use to help child solve the problem. For example, if you add natural numbers, the sum will be more than any of the numbers. Now, when you generalize this to saying that when you add any numbers, you will get the sum is going to be larger, or when you multiply any two numbers, the multiplication is going to be larger. You end up in difficult situations when you are dealing with things which are not natural numbers. So, but in some sense, as teachers and as a society, we are afraid of mathematics. And I think it's that fear that we must first address. And that fear can only be addressed by assuming that it is all right to make mistakes. And learning can only happen when you are allowing yourself to make mistakes. For example, in speaking, for example, you want to speak English. If you hesitate to speak English because you may speak incorrectly, or if I am in Telangana and I want to speak Telugu and I am afraid to speak Telugu because my pronunciation will not be appropriate, and I fear people may laugh at me, then my ability to learn the language, whether it is Telugu or English, will be hindered. As a child, when we are at home, we pick up languages with greater confidence than we do it in school. We learn to speak much better at home because we are not afraid of mispronouncing, as we may say, or using the wrong word, or making connections which perhaps are not. So in one sense, I think the basic problem when we think in terms of mathematics is the fact that we have understood mathematics to be one answer, one method subject. And the entire curriculum is focused around making the child get to that one answer to one problem, and be able to do that using one method that is particularly formulated by the teacher. Very often in schools, children are discouraged to use alternative strategies. So even though the NCERT books in the last 10 years at least that I know have started, or maybe even more, 20 years, have started talking about encouraging many different ways. And many other books in the primary level talked about encouraging children to come up with many different strategies. And they in fact showed that a problem could be done with different strategies. The emphasis in the classroom is to use that one particular strategy and use that only that. And even if the child has been able to get to the answer, solve the question correctly, it may be crossed and marked wrong if the child has not used the correct strategy. So I think there is a big fear here that if the child is using the strategy, she may not be able to use that strategy always. And that in different situations, perhaps the strategy she has developed is not generalizable. And therefore, it is simpler to use a strategy which has been used for many years and which has been, in a sense, formalized to be used for all situations. I feel that, therefore, there is a need to understand as a teaching and learning community that mathematics is not about finding one particular solution by one particular method to a problem. So if I think in terms of proofs, again, the problem is similar. We have a standard set of statements and we have a standard set of proofs. And we have to actually ensure that the proofs that we are given are, the logic is followed in the same manner. If I use a different logic, then there is no patience in the examiner or the teacher to examine whether what I'm doing, the process I'm following, whether that makes sense and whether that is meaningful or not. So I think the basic issue that we have at hand is that when we think in terms of mathematics, risk taking is akin to saying that you are allowed to do mathematics. You are not a calculator. You are not a programmed process which delivers answers, but you are a person who is creative and you can think of new answers, you can think of new questions. And I think one of the things that again we have emphasized in the books recently is the fact that the children must be encouraged to form new problems. So it's not merely about solving a problem, but it's also about thinking about what problems you can set others, you can set yourself, so that you think beyond um, just the fact of finding solutions. Um, so if a mathematician is not exploring, if the is not looking for new patterns, not looking for new statements to prove. So mathematics develops by people making conjectures. And these conjectures could be some things which perhaps are not emerge from their experience and their knowledge, but they don't immediately emerge from them as where they can reach immediately. It's not that they know how to reach the proof of that conjecture. But the point is that unless you come up with many conjectures and you try and explore how to reach the proof of that conjecture, or to say that it's not correct, you are not going to be able to discover new mathematics. And any mathematics student, even in class 5, is a creator of new mathematics. So if I say that at what stage should I begin risk taking, I would say that you can't teach any mathematics without allowing the child the ability to explore, experiment, make mistakes. So right from the beginning, and the child does that in her daily life. When you are playing something, you try and organize things in a space, and in that you also think about, can I place it this? Can I place it like this? A tangram that is available to you, making shapes from that, is again an exercise of exploration, and you will go through many cycles of using it in different ways to make new shapes, or even the shapes that are already given to you. How do you reach them? So I don't want, it will be ridiculous for me to say that I give you tangrams and also give you the steps. And then I ask you to say that, can you follow those steps and make that the entire 7 pieces together into a square? That I don't think anyone would like to think is a useful exercise. But if you think of the entire mathematics program in the school, that is what we do. We give the child problems of verbal problems, and we give them hints that if you see in all, or kul mila ke in Hindi, add the numbers. If you see how much remains, then you subtract the numbers. Now, these kinds of hints, these kinds of suggestions, which sometimes can also be wrong, and therefore they can mislead the child. But more importantly, they prevent the child from being able to formulate her own understanding of how to read a mathematical text, how to discover a way forward, and therefore how to create a mathematical text. So in some things that he needs to do in order to make her life more efficient, more useful, using mathematics, which we call in daily life. It's, you may call it mathematization, you can call it anything. It requires the child to be able to formulate new problems for herself so that she can make the best decisions for what she wants to do. And in order to do that, she needs to be able to think of the situation and think of all the numbers, all the parameters in that situation, and then try and figure out what is it that she can do so that she can make it better. And to reach a better solution, what are the kind of steps she has to take? And therefore, it is necessary for her to be able to think of new ways of constructing the building, the distributing the land, do whatever, so that you can move away from the safe space. We call it thinking out of the box, but I don't think there is any meaning of thinking out of the box. Thinking has to be out of the box if it has to make any sense. Otherwise, it is just following prescriptions. So I think we need to really think about mathematics as a subject where the child is not following directions, but actually doing some new things on her own with numbers or space, with logic, and with systems of proofs that she has to follow. I think I'll stop here and we'll come back later if there are questions on that. Thank you.
Thank you very much, sir, for that deeply reflective presentation. Your thoughts on risk, curiosity, and emotional safety in mathematics classrooms offer us a new lens to view learning, not just as content delivery, but as a courageous act of exploration. A wonderful start to the conversation. Thank you very much. Now I invite Professor V. Sudhakar Venukapalli ji to take us further into today's theme. Welcome, sir. Welcome to the discussion. Sir, kindly unmute yourself, sir. We can't hear you. Sir, we can't hear you, sir. We are very sorry, there is some technical glitch. So we will move on to the next speaker. I now welcome Railu Surji to offer his reflection. We welcome Railu Surji to the panel discussion. Welcome, sir. Sir, kindly unmute yourself, sir.
Good evening, everybody. And special salutations to Divan sir. He's our guru for many years and still now also. So here I want to talk in context of student and teacher. Okay, first of all, if who has to take risk first is teacher. So there is a lot of problems behind the teacher to take risk. The one is number one is he has to be professionally very development he needs, and he needs lots of psychological theories, at least child concern. Then from the student concern also, if you take academic risk, the child has to take. So even now at present, if you see medical students, they are reading all in one book. Engineering students, they are reading all in one book. So they do not go to reference books, and they do not want actual theory or actual content, but just passing through and getting marks. This kind of mindset, if doesn't shift from parents and especially students, he may not give full cooperation to teacher. And why? Because from the childhood, the children are habituated to some kind of framework within the school. Okay, as Divan sir said, in the beginning, in the primary schools, we have to remove a big fear about the mathematics. Okay, especially the teachers struggle and children struggle when we go for numbers. Okay, the concepts of numbers that the teacher has to understand a lot, because when we say natural numbers, okay, natural numbers, what do you mean by natural number? What is the difference between 1 and 2 and natural numbers and rational numbers? There will be a clear clarity picture should be there, because in universe natural numbers or whole numbers are very less, but rational numbers are many. Wherever we go, we see rational number, but in specific context only we will see the natural numbers or whole numbers. Okay, so that in between 1 and 2, there are no numbers. But in reality, the child knows so many numbers are there, especially in counting paise or like that. So that has to be clear cut. We have to give and one. So one banana and one apple. So this units also, definition of units also, teacher has to clearly kept in the mindset of the children. So one banana, another banana also may not be equal unless it may be become unit. That's the reason piano, the first he defined numbers, natural numbers, as one as a unit, and the same unit is added to the previous one, so it will become only one plus, he said, one successor means next number. So one plus is two. Then when one plus is there, then one previous number also there, predecessor number also there. So predecessor number, one and successor, there is a sequence and one unit, one unit, one unit. So like that, lots of practice should be there in primary classes to understand actual natural numbers. Then the children can understand the whole numbers or even integers also. The big problem, big fear in the children is rules are differ from natural number to integers to rational numbers. So some rules may be same in all numbers, some rules may be differ. So where the differ are there, the children has to be clearly practiced. Okay, practices are of two types. Okay, when Patanjali said that abhyasa vairagyabhyam and karmasu kaushalam. Practice is differ and karma is differ. Okay, in daily life, if the child uses keep in you that what he practiced, then it will become sukaushalam. Sukaushalam means well skill. The skills the child will get. So mathematics is full of skills. Okay, even thinking also. So these thinking levels also should be very flexible. Okay, very flexible means if the child, whatever the child says, okay, then teacher has to accept. So I will tell a small story about Carl Lewis. So Carl Lewis is a very good mathematician, and he wrote a very good book, Alice in the Wonderland. So that is full of logic, mathematics, and physics, and chemistry also. Okay, all the principles. He never mentioned this is mathematics, or this is physics, or this is chemistry, but he prepared a very good story. Okay, so staying rent in a professor's home. That professor's wife asked him to teach some mathematics to his daughter, little daughter. So on her name only, he developed Alice in the Wonderland. Okay, so that Alice, so he was generally every day Alice comes to his room, that like Carl Lewis room, and he used to talk so many things, so much of things, and so many explanations, and so much of her experiences, her thoughts. She used to okay tell, but he never taught any mathematics. So when that lady landlord asked to come to dinner, so that landlord lady asked his husband to question something to child, whether how much mathematics the child is learning. So he asked, father asked that simply, what is 2 times 2? The child said 11. So that Carl Lewis immediately said that, yeah, she told 11 is good, correct answer. Okay, how it is correct? 2 times 2 is 4. So 2 times 2 is 4 in 10 base decimal system, but 2 times 2 is 11 in base to 3. So he explained. So the children needs where they did mistakes. Is there any mathematics there? So any expression will have innerly a good logic and reasoning for any human being. Okay, whatever he says, there will be definitely a logic. If the child, if the teacher understands, then he can able to take to risk with his level of professional development and his level of professional achievement. Okay, so he started saying that how it is 3 and how any number can be. That child asked, any number can be 2 times 2. Okay, he said, okay, you say 9 is also, it is possible, 8 is also possible, 7 is also possible, but in different bases. Okay, so such capacity building should be there within the teacher. So that mindset has to be changed, and that kind of, so habit of development in that, and understanding what kind of questions children ask at least. Okay, then children are encouraged to ask some questions in classrooms, and teacher has to definitely give a chance. So naturally, in if we go to schools and even in primary class also, the teacher asks question, she waits only half second or 1 second, half second or 1 second or 2 seconds, then the teacher gives correct answer. Then later, after 3, 4, 5 times repeatedly, the teacher is saying the answer for her question. What the children understand? Yeah, teacher will ask the question and she will tell, no need of answering from us. So that kind of breaking the habits we have to develop within the classroom, and within the children, and that. So this kind of in other words, this kind of scaffolding. So scaffold is very much important. One more thing is there, in mathematics, always we keep only one answer. Okay, as Divan sir said, mathematics problem means, even under guidance of Divan sir, we developed mathematics textbooks in Telangana and Andhra. So when our committee, okay, suggested to remove the answers at the end of each, in previous tradition was that at the end of the textbooks, there will be answers for all questions. So we thought that we can remove the answer so that the child and teacher will check their own self, and they come to conclusion that they come to confidence that my answer is correct because I did correct, my logic and reasoning is correct. Okay, such kind. Then there was a very protest from the parents and teachers and even children also. Without answer, how can we confirm that my answer is correct or not, like that? Okay, so that kind of, okay, dependency on textbook, dependency on teacher, and that made children to, okay, make mum or only listeners, only listening. So that thing. And one more thing we brought into problems, creating problems. Okay, at least creating a conjecture. So problems, all students may not okay, create problems. Okay, some children may create problem, but the wrong message has gone. Every child has to create the problem, then only he will get marks. So if other child is creating the problem, so that problem can be distributed to all the classroom children to test it. Okay, when the testing is also a very good fear within the children. If anybody is speaking about his answer as his problem, children will fear, and their brain also gets to shrink. Okay, their brains will not be open. Okay, they will feel a little bit stress. So all the answers, all the questions may not have correct answers. If the answer is wrong, so the children has to identify the reason for the logic for that, and what are the answers we got, and what kind of rules or set of rules or axioms or theories we did not follow that. And if you follow, what happens? If we do not follow, what happens? Then the fear will gone. So fear is because of, according to psychology, fear is because of ignorance. If we do not have any knowledge about chipkali or like the lizard, like that, we afraid. Even snakes, we afraid because we don't know the nature of the snake, when it hisses, when it bites, or like that. So if once the child get information, all information, know about the nature of that, the child will okay, control, and the child starts to play with the things. So here another idea, another dimension is language also. Okay, we do not develop any language from the primary section. Okay, so very small sentences we can make. Okay, in language, how we make in our literature language, Telugu language or English language or Hindi language, like that, a small sentences, how this sentence can be in mathematical language. Okay, so that kind of information also should be there. That kind of okay, perspective also should be there within the teacher. And the thing, another thing is, so what are the benefits if we see? So even parents, they will emotionally they will come out and they will join in the schools. So many people afraid, even educated people also afraid. We inquired so many people here, so they afraid that because two things in schools. One is the lack of teacher. Another is teachers do not teach. So how much how they get marks more and more. Okay, they teach concepts are like that. The children learn and do not learn. So it will take lots of time. Okay, here risk also, it has lots of time consuming is there. The teacher has to understand the time and marks also. Okay, if we see in India, more grade inflation is there. So we give more marks for the children, even in degree colleges, in universities, and so many colleges we see. If the child is not up to that mark, also we give more marks. Okay, when we were studying in our degree, so getting 60% of marks is very difficult for us. Okay, now all the children are getting 80, 90, 98%, 99%. Okay, if in marks we cannot compete with the younger children. Okay, when we go for interviews for nowadays after retirement, where we go. So that is grade inflation. Even the grade inflation is giving wrong notion among parents also. Okay, parent, what he understands, okay, my child is getting 80%, 90%, but he is not getting job. Okay, so teacher has to take compulsory risk in assessment or evaluation also. Okay, and no problem. The child gets low marks also if he has skills and if he has concepts. Definitely, in next class he will get very good marks and that. Okay, we have to break that running behind the marks. Okay, from the parents or that. For this, NGOs also has to take a decision, and they have to encourage children and parent and discourage these all-in-ones and guides and like that. So these guides printings also should be given to NCRT or SCRT on the lines of SCRT or NCRT rules. The people should prepare the guides. Okay, if we see the American textbooks, reference books, okay, we will wonder. Okay, one problem will be there, like that one similar problems, parallel problems. Okay, in that, within that, a small that puzzle making problems, like that, so many types of books are there. Okay, so I was wondered in fifth class there was a problem given that concept is of regression in statistics, very higher statistics. Okay, if the child blows the air balloon, okay, it bulges for one puff, it bulges this much. In second puff, it bulges for two puff. So they asked for a constructing of a equation, a straight line. Okay, so that after that, how many that this much of volume or that okay circumference will come of that balloon, like that problems are there. Okay, in fifth, sixth class problems. Okay, like that they are preparing a different of types of problems. So such things NCRT or SCRT has to take that initiation and control these guides, all-in-one guides. And okay, very important problem. There is another theory is there that children are teacher are teaching very important things, and children are learning very important things. So for each class, the children are okay leaving 70% of the syllabus. Okay, after 10 classes, you see how much for 1,000 marks paper, they're preparing only 300 marks paper, 700 marks paper they are losing. So all these are lots of risk taking for teacher and preparing curriculum and administrators and educationists and so many things. It's a very big challenge for everybody. So at least everybody has to think and okay, take a decision. This is not a pedagogical shift or like that. Mindset shift should be done from the parents, teachers, and students also, and then only students will go give very good cooperation for the children and encourage. So here children will remove the fear. Okay, naturally the children will talk a lot with the teacher. That is very much important. Every feeling the child has to convey to the teacher, then the teacher can understand how far that. Even formative assessment also tells the same thing, whether it is formed or that, or in other way also can be teach the same thing in different methods. Okay, and in training programs also we interact with the teachers that I request the teachers, if you teach this year this one problem you suggest, next year you should not okay adopt that process, or you have to for other. And one more thing is there, for from class 6 and for class 6 to 10th, we have to develop how the same thing will be in algebra, how the same thing will be the arithmetic, how the same thing will be, if possible, in geometry. Is there any connection? Okay, GeoGebra is there. Okay, so in my opinion, GeoGebra can be introduced from class 4th or 5th. Okay, that is very good tool, and if teacher can do very innovations to understand, and children are very enthusiastic to do that. Okay, and teacher also think about his lesson planning or like that in the same way. Okay, then any questions are there, then we can I will come back. Thank you. Thank you so much.
Thank you, sir, for your honest and thoughtful reflections. Your years in teacher education highlight the importance of equipping educators with the right training, attitude, and empathy to build emotionally safe, risk-friendly classrooms. So may I now invite our next speaker, Professor Sudhakarji, to add his ideas to the discussion. Welcome, sir.
Good evening, madam. Am I audible to you?
Yes, yes, sir.
Respected Dr. Santoshi Shukla, ma'am, and my close friend Hudayakant Diwan, sir, and respected Rayalu, sir, and Ramaya, sir, who have been working in the field of mathematics education for a long time. And we have been trained under them. All the three people I know, I know about their contributions. And I am privileged and honored to be here. And also especially the distinguished participants who have coming with a lot of background in mathematics. I am not a mathematics professional. I don't teach mathematics education or mathematics per se, but I have some random thoughts about mathematics education and risk-taking behavior in mathematics. Because my basic interest is in philosophy of mathematics and mathematical logic. So from that perspective, I try to look at, added to my psychology background, and I try to look at the risk-taking behavior in mathematics from that perspective. And I'm very much grateful to Santoshi Shukla madam for giving me this great opportunity to explore this particular subject. Friends, when you talk about risk, there are many connotations of the word risk. Before we go to risk behavior in mathematics, risk behavior of children and teachers in mathematics, I just try to understand what is this risk. See, children are pushed into risk. Who is pushing them into risk? This is an important question. You see, parents, community, teachers, textbooks, the entire environment, the entire so-called ecosystem is creating, that is becoming a source for this risk. This is very important. How we have become risk, the source of risk for children. This is a very important question. We need to address this. I'll come to that point. And before entering into this, I just try to distinguish the 5 connotations, 5 different ideas of risk, which was distinguished by a famous philosopher of mathematics, Hansen. According to him, risk as an unwanted event which may or may not occur. Risk as an unwanted event which may or may not occur. This is the number 1. And number 2, the cause of an unwanted event which may or may not occur. So risk may be the cause of an unwanted event which may or may not occur. The third one is the probability of an unwanted event which may or may not occur. This is very much relevant to us. The probability of an unwanted event which may or may not occur. This is the number 3. Number 4, the fact that a decision is made under conditions of known probabilities. You see, we make certain decisions under conditions of known probabilities. This itself is a, leading to risk. The 5th one, the final one, he says, the statistical expectation value of unwanted events which may or may not occur. There are 5 important, ways of understanding risk according to Hansen. Friends, there are lots of things which enter into, child's perception of risk. This is important. How child is perceiving risk is very important. Child is perceiving risk of so many constraints, so many, factors. What are so many factors which around the child? Maybe affective factors, emotional, cognitive factors, contextual factors, and certain factors which are individual to the child himself or herself. All these things, which influence child's perception of risk. Once child perceives risk, the idea which he forms about the risk, that idea in turn influences his action. Please try to understand this particular, connection. A child's action, child's problem solving, entering into problem solving process depends on how child is forming an idea about risk. See, there are other things, maybe risk like risk perception. Children may show risk aversion also. Some people, some children, some students, some teachers, and some children and some teachers, they take risk-taking behavior is also there. So risk itself in classroom situations, mathematics classroom situations, like other classrooms in everyday life, because every day is becoming very complex now. Every moment is becoming complex now. When you enter into Google, when you enter into laptop, when you enter into social media, everywhere you are at risk. So the understanding risk is such a significant concept. I must, thank Santoshi Madam for identifying this particular area of study. How challenging our life is, because every moment there is uncertainty. Because uncertainty is very important concept which is associated with risk. So there is uncertain, the world itself is becoming uncertain. We are at risk. Every day, we have been facing that risk. Friends, when you think about child's perception of risk, and when child enters into problem solving or risk-taking behavior to solve a problem, there are lots of filters, lots of biases, socio-economic and socio-emotional biases and cognitive biases, cognitive filters. These all play a role in solving a problem. Generally, as teachers, we don't explore these things. We are totally blind to this because we don't have any know-how about this. We have not started exploring this. Our awareness is zero in this because we don't show much interest in sitting with the child, like a clinical research. We never encourage that kind of thing in our classrooms. The way we address children in mathematics classroom is like other classrooms. But mathematics classrooms requires a different kind of pedagogical practice. Because children are pushed into some kind of risk. There is a diversity, there is a plurality, there is a differentiality within the classroom situations. And that itself is challenging to us. That itself pushes teachers into certain risk. So risk is everywhere. Risk is universal now. Risk is, it has become so complex today. Friends, one more important point which I want to highlight here, our obsession with rationality. We always try to rationalize things. This we have borrowed from, European civilization, colonial models. We always try to, rationalize, and we try to teach children, instruct children, try to educate children through reason, rationality. We push that this is the way you have to think. We give structures to them. We give templates to them. We ask them to categorize the things, classify the things in that particular fashion. So these are the such kind of strict instructive technologies which we adopt in the classroom. Okay. These things we have actually, as I mentioned, from enlightenment models, so-called enlightenment rationality models, which we have borrowed and pushed into mathematics textbooks and mathematics pedagogy, mathematics education, and entire understanding of mathematics itself. One important point which I want to mention here is that mathematics problem solving is not necessarily a rational process. Reason might support you to certain extent, but there are certain other things. Rationality, when you talk about constructing reasons, constructing rational explanations and problem solving, that may be a conscious process. But there are unconscious motives. There is a huge area called unconscious, which motivates children to address the risk behavior. This is a very important point. Generally, we never explore that. So every teacher need to become a psychoanalyst to a certain extent. So he has to explore what kind of thoughts, what kind of feelings, what kind of emotions are hidden in child's unconscious, and that exploring children's unconscious behavior. Unconscious, I don't say behavior, it's unconscious itself. That matters a lot in mathematics education. These are the things, there are different modes of training children, but we never do that. We always ask them to do problems in a certain fashion, but there is intuition. Intuition is a one mode of contemplation, speculation, dialogue. There is a monologue, child speaking to himself or herself. There are lots of things, which multiple methods we need to bring into the classrooms so that, child can be equipped to address the needs of, how to handle, the risky situation, in problem solving. And, that such kind of deep thinking, how, for example, I'll give you one more important aspect, that language, we never, focus on that. But the language also pushes child into certain risk situations. Decoding the text, mathematics text, mathematics has its own language. But when child is reading mathematics text, child forms certain registers, cognitive registers. Cognitive register, I mean here, child has his or her own meanings with which he forms a register in the mind. Such cognitive registers play an important role in addressing risk situations in problem solving. So how child is trying to relate the object, here maybe the object, maybe the numbers, and in mathematics, maybe, and how he or she is trying to translate in them in terms of certain symbols, certain signs, and how the signs and symbols child tries to interpret. Mathematics learning is primarily learning of language. It is a linguistic enterprise itself. Okay, that we generally forget about it. So every meaning, every word has its semiotic space, meaning space. So how child is trying to capture, forming that meaning semiotic space of each and every word. When you take plus, minus, any symbol, any sign, any word in mathematics. So empowering children in mathematical language is also helpful to strengthen their cognitive abilities. That's a very important aspect of it. When mathematical language, how it operates in the class and how his home language or mother tongue language or the other foreign language, how this language play a role vis-a-vis with, with the mathematical language, such kind of crisscrossing codes, how child switches the codes from one language to another language to understand. This is also very important subject to explore in understanding risk behavior. Friends, I don't know how much time I have, but two more ideas which I would like to flash. One is important idea which was has come from bounded rationality. This is a very important idea which has come from Simon and others. The cognitive scientists. They explain that bounded rationality is a very important concept, which assumes that human beings are limited in their cognitive potential. Okay. When we are making certain decisions, our decisions are based on our limited cognitive potential. We don't have unlimited cognitive potential. That is not there. This particular theory in cognitive psychology, the dominant theory in cognitive psychology assumes that, like our sensory organs are defined in a particular range. For example, what you see, what you taste, what you, blah, blah, blah. All the sensory organs have defined in certain range. In the same way, Simon and others are believing that even, your cognitive potentials, the way you conceptualize rationality itself is also defined, is also, it also operates in certain range. So you don't have unlimited range. So whatever information you gather is the only limited information. With that limited information, you visualize the situation, you imagine the situation about, if I solve this problem, what kind of result I am expecting. This is a very, these are all psychological processes associated with problem solving. Because when a child does problem solving, he imagines, what kind of result, the entire process the child imagines. If child is, not able to do that, we need to explore why. For all these things, teachers need to be equipped with lot of theoretical apparatus. The latest theories. That's why I always take the spirit from Bayesian statistic probability theory, that not only just the existing probability, the evidence, but also every day I need to update myself. So that I go with a different kind of accumulated knowledge or accumulated probabilities, that kind of thing. So friends, this is an important aspect, in problem solving. When we are talking about in problem solving, risk taking and problem solving, we have limited potential. We have limited knowledge. We don't have, unlimited knowledge. This is a very important point to understand. The last point which I want to say and finish this. You see, there are some psychologists which are talking about fuzzy trace theory. Fuzzy trace theory is talking about whenever you are trying to solve a problem, you are trying to use two important registers or two important memories. One memory is verbatim memory, okay, verbatim trace. Another is gist memory. When you look at the environment, or when you're interacting with someone, or when you're encountering a text in mathematics, or when you're encountering a problem, what you gather, lot of information, consciously whatever you do, that will become a verbatim memory, which you can easily retrieve. But there is also a memory when you look at a text you try to make meaning out of it. When you're interacting with someone, you try to make meaning of that conversation, and that kind of meaning also you register in your memory. That is gist memory. So whenever you are trying to, uh, solve a problem, when you are in the risk situation, when you are trying to problem, how these two verbatim memory and the gist memory play a role in risk-taking behavior, this we need to understand. It's a very complex process. So friends, my thinking is children are pushed into risk because of so many reasons, because we are responsible to some extent to push them in certain artificial kind of risk situations, which have become real for them. And we need to understand how we are doing that. Our obsession with so-called rational faculties and reason, blah, blah, blah. And how best we can explore the other modes of unconscious, ways of looking at the world. With this brief uh, idea, I may be wrong in my interpretations, but I thank you for giving this great opportunity. I will come back if there are any questions, and I don't have answers to many questions, but I try to grapple some of them. Thank you very much.
It was a very thought-provoking session, sir. Thank you, sir, for weaving together the psychological and philosophical underpinnings of risk-taking in education. Your insights into student motivation, fear, and teacher mindset are particularly relevant as we rethink our teaching methods for long-term academic growth and emotional well-being. Thank you very much, sir. And finally, I invite Dr. Ramaya ji to conclude the panel presentation with his discussion. Welcome, sir, to the panel discussion. Please unmute yourself, sir.
Please unmute me. I'm unable to get it. Yeah, now.
Yeah, I'm sorry, sir. Yeah, we have given you co-host permission.
Yeah, okay. Thank you. It's a very good evening, one and all. It's a great pleasure and honor to me. So, in front of our mathematics gurus, Bhishmacharya, Professor Divan sir, and eminent educationist, Professor Sudhakar sir, and my guru Rahul sir. It's a great pleasure. It's an eye-opening session to me. And Dr. Santoshi, you have taken a wonderful initiative for the very current topic which is to be addressed. And respected mathematics teachers and academicians across the country. A very good evening to one and all. Really, it's after listening to the sir's lectures, it's a really very honor and very eye-opening to the everyone. Risk taking with respect to the student means the willingness of the students to attempt the unfamiliar problems and also making conjectures and also accepting the failures also. So this is a part of as they're learning. So here, as Sudhakar sir described the many facts, psychological and other facts. So here we can, what are the concerns of the risk taking factors in the classroom? that is a psychological and pedagogical dimensions. One is fear of failure and performance anxiety and a fixed mindset. So here the fear of failure in the means many students hesitate to respond the whole class discussion or in the when we pose a question in the classroom also. So that is also the effect that leads to the silence and avoiding or copying from others also. So for example, a student is hesitate to attempt a new method to solve a quadratic equation or a problem through, for example, linear equation with two variables. So there is a general procedure is there by guessing also there by the random. There are for a problem there are many methods. So teachers regarding this, so teachers try to make the child to think on his own way. So that strategy definitely when you allow the student to think on their own way, so they can able to speak. So that is the concern of the a teacher. So here also the performance anxiety. Whenever a teacher tries to judge in the classroom, the pressure of being evaluated in the classroom by the teacher definitely inhibits the students' participation. So, for example, if you pose a question in the whole class, so we will solve it. If you don't solve the problem, I will beat you. This kind of attitude definitely lock the mouth of the students. So they feel that the teacher will be judging like this. So I may be wrong. So even a capable student also sometimes they kept quiet in the classroom. So this is the kind of concern in the classroom. And again, one more a fixed mindset is a one of the concerns of the our risk-taking classroom situation. The belief of the mathematics teacher that is the talent, the mathematical talent is very innate and it cannot be developed. So they won't learn like this. So if you could have that kind of fixed mindset, that is also a concern of the present classroom scenario. So now, what is the theoretical backing or the support for the risk-taking behavior in the classroom? For example, the intelligence and abilities can grow and with the effort of strategies and help of the others. So that is a big concern. That is a big backing for the teachers. So we can develop this slowly. We can develop the intelligence and the mathematical abilities, and through a particular strategies and helping the students in other way like that. And also, for example, when students believe that a struggle and to effort lead to learning, they are more willing to take intellectual risks. For example, uh, here a teacher has to focus more on the process rather than the results in the problem solving. As our Divan sir said, problem solving also make the child as a stakeholder of the problem solving. So the problem solving is a problem with the students' own problem. They can let them think and they let them thought about what are the concepts are there, what is the given, so how to solve the problem. Let the child to think on their own. Let them try on the classroom. So that is a very important. So for this, a psychological thing is there when, as per the Vygotsky theory, zone of proximal development. So the core idea of the ZPD is the gap between the what a learner can do independently and what they can do with the guidance of the others, either teacher or the co-learner. So here, encouraging students to operate just outside their comfort zone when often they require the help of the, suppose a children knows the formula for a problem solving, they write the formula while simplifying they need some other help. So that kind of, if you could guide them, the guided practice is there or guided help is there, so then definitely they will be reaching the results. So this is the way we need the psychological backing. And one more thing, and self-determination theory. So it is the need to feel a control of one's own learning. the need to feel capable and effective. I can do this problem. This is the kind of confidence we have to build among the children. So, and again, the need of feel connectedness with the others, and again, connecting with others while solving problem and while discussing regarding a particular issue also, we can connect to the others also. So when students feel safe, competent, and connected, they are more willing to participate and they take intellectual tasks. So for example, in our classroom, teacher has to create a kind of the concern, for example, for the fear and failure of the to eradicate the phobia of mathematics. So teacher should create such kind of environment in the classroom by starting by entering into the classroom. An enthusiastic teacher, they can start with some puzzle, an ice-breaking activity. When you enter into the classroom, oh, my teacher gives something, a challenge to me, I can speak, I can respond. So child should have that kind of confidence. So that kind of that kind of activity should be inculcated in the classroom. So for the dragging the attention of the children, for making the every child is attentive and responding to the particular topic. So today we are going to teach directly or indirectly. Teacher can take many strategies: mind mapping, brainstorming, and puzzle, or a simple 1 minute, 2 minute story with a kind of twisting. What do you think about like this? So these kind of strategies definitely definitely reduce the fear of our failure. And again, while children are solving problems, if somebody some student may do the mistakes are common, let the child celebrate their mistakes. Let the child to feel learning. Mistakes are the stepping stones for learning, and learning from mistakes allow the children such kind of habituation, learning from mistake. So that kind of when you again when you have done like this, it is you're wrong, you don't know like this. If you scold and if you have a kind of teacher attitude, is very dominating attitude is there, definitely child stops their mouth and they stop their thinking. So when you allow the child, and again, that is called individualized teaching. So when a guided practice is there, edit the mistakes of the children and encourage them. It is you have done the why you have done the mistake like this. Suppose if they could justify their mistake also, so it is not like that. The kind of discourse should be there between the student and the teacher. That is very important. So there should not be a fixed mindset. There should be a growth mindset for the teacher. And again, risk taking regarding the teacher. So teacher should have the emotional balance. They create a conducive classroom environment and which encourages the child to speak out. So what the here now one more thing is that now we have been converted into the English medium schools, but again there is a problem of asking questions also. So there teacher has to encourage multilingual approach in the classroom practice, teaching learning process. So while explaining, so while if the thought process is not in English, so they can allow to speak in their mother tongue, either Telugu or whatever the mother tongue they have. So that kind of environment teacher should inculcate in the classroom. So the classroom that can encourages risk taking is not one where mistakes are punished. There is no punishment, but where curiosity and encourage and courage are rewarded. That is, you have to create the curiosity of learning and courage to solve a problem. I can solve a problem, though it is to where I am stopping, where I am getting stuck with the problem solving. So as per George Polya problem solving steps, there are 4 steps are there. So understanding the problem, how to devise a plan to solve a problem, and carrying out the plan, and verifying the answer. So in the 4 stages, make the child as a stakeholder of the problem solving. So let the child to think on his own way. So for a problem, there may be open-ended answers will be there. I mean open-ended process, and there are different processes are there to reach particular answer. So that kind of approach is very essential for the classroom. Similarly, creating safe learning atmosphere in the classroom is very, very important. That is what emotional safety of the children. So classroom culture where mistakes are accepted and valued. That is very important. Here, error analysis should be done by the teacher. Why most of the students are doing these kind of mistakes? So what is the reason behind that? So when a teacher analyzes the common errors of the students, then he rethinks and then he plans for the conceptual understanding. So they are not supposed to do these kind of mistakes. For that, they need a guided practice or an activity like that. And again, respectful communication in the classroom also is very important. Encouraging students to listen questions and respond without fear and ridicule. So that is very important in the classroom. So encouraging the children to ask any question regarding the particular teaching learning concept. So while teaching learning process is going on, so teacher can ask the different and very important task, point in the pivotal thing in the classroom is the teacher attitude. The mathematics teacher attitude is very, very important. He is not an autonomy, he is not an authority to control over class. You have to, as a mathematics teacher, we have to carry the emotions of all the children and their levels, and modeling curiosity, admitting errors, and praising effort also. Some student is solving a problem at the half of this procedure, he stops. So you have done well, your effort is good, so you can move like this. If you give kind of hint, that is called ZPD, we have discussed. So the zone of proximal development, they know something, you are giving some hints, let them catch the point. Some at the same time, this kind of coherence should be there in the classroom. So really, a concrete strategies should be taken in the classroom. Establish, a good, culture of, questioning. Mistakes help us learn. Students should feel that, oh, my teacher identified my mistake. He made me, know my mistakes. So I can learn from mistakes. That kind of, environment could be created. So, and again, the teacher should scaffold risk taking, pairing the student, and I mean pair and group encouraging to do group discussions, group activities, and use a different kind of strategies. Here, for the nowadays we are in the era of digital classroom. So as Rahel sir said, whatever the particular ICT tool which is required in the to probe the questions, to think the students, you can use kind of ICT tools. For example, if you want to discuss regarding a particular topic, there you can use a quizzes. There you can use a mathematics, GeoGebra or RoboCompass, anything, whatever the where it demands the kind of ICT tools where an interactive simulations are there. So let the child come and discuss. Here, as Sudhakar sir said, mathematics has its own language. So let the students' thoughts, students' experiences convert into mathematical language where they can express the real life experience in terms of mathematical language. That is very important. Here also, one more thing, teacher, action is very important. Set and teacher attitude we speak out. Modeling curiosity is very important. To create curiosity and interest among the children, to again I can say, to reduce or eradicate the fear of learning mathematics and failure of attempting a problem. It depends upon the teacher attitude and the kind of environment teacher creates in the classroom. That is very important. Let us try this method. Why can't you try? So let us try. Do like this. So the discourse between the teacher and the students, that really an encouraging mode definitely gives a boost to the children. And again, praising effort over the results. For example, a child unable to get the result and a final product, final answer, but he is trying in the proper way, he is doing something, so you are doing well, this is the way you have to approach, then you do like this. If you encourage that kind of appreciation, so definitely they will be getting the boost in solving the problem. So, and again, the strategies for foster safety and risk taking is very important. Establish a good discussion norms. So what to discuss, how to discuss, and what kind of questions can be posed in the classroom regarding a particular question. So, and again, how to, uh, the discussion in the classroom is very important. Use sentences and support mathematical thinking regarding the classroom transaction. So, for example, I wonder if you could do what if you try reversing the operation. For example, if a problem is there, so you can create, as Rayulu sir said, every child cannot create the problem, but they can create a parallel problem. So by giving a small guidance and let the children create their own problem, let them solve. So this is the kind of, can you try the solve the problem in other way? So let us give an open-ended questions. This kind of is very important. Provide low stakes of tasks. So activities that you are going to give in the classroom should be in a gradational way, should be in a linked prerequisites. What are the, for example, if you are teaching a particular similarity of the similar triangles chapter, you have to identify whether the child is all the children are able to get the prerequisites which are very important to learn the similarity of the triangles. So what types of triangles, properties of triangles. So let us explore the children on their own about the prerequisites of the the particular chapter. So at the same time, teacher should provide a clear-cut conceptual understanding. For every conceptual understanding, teachers should encourage kind of joyful learning activities, mathematical laboratory activities. So as our textbook is designed in such a way, textbook is not only the content organization there, according to the as a really our Udaykant Diwan sir, under the able guidance of Udaykant Diwan sir and our Rayulu sir, our textbooks were designed in such a way. There is a pedagogical approach, constructive approach is there, where we are giving a space for the child to construct a knowledge in the mathematics classroom. So that spirit of the textbook we have to carry in the classroom. So where child is given an opportunity to respond, where a child is given to an opportunity to think, then definitely there starts a mathematical thinking. That is the bringing up the or developing the mathematical abilities such as problem solving, reasoning, and mathematical communication, and in the visualization of the mathematical concepts. So that is nothing but a mathematization of the child thought process. So here, as a teacher, this is very important. One is scaffolding, risk taking. That is also gradually build confidence through the support mechanisms. So there are teachers should have an idea. Heterogeneous group can be formed. A very bright children, some low children, low achievers. So they can be in a group. They are not separated to. Sometimes teacher can support the by taking the remedial classes. Though are the in our classroom there are two extreme. Very low students are the density is very high, and the talented students are very low. So to bring whatever we have to bring the the low achievers, that is basic performers to the average level, and average level performer should bring to the high end. And moreover, we have to streamline the learning process by achieving the learning outcomes. So here, one more thing we have to think about, emotional safety of the children is very important. That is, in a mathematics classroom, what about the attitude, the behavior? So teacher is very intelligent, is no doubt at all. But the emotional balance of the mathematics teacher and respecting the students' responses, and allowing the students mistakes and encouraging them, that is very important in the classroom. Here, one more thing we'd like to do. So encouraging the mathematical exploration and promote conjecturing and reasoning, that is very important through concrete activities for the conceptualizing the different abstract concept is there. So let the teacher should bring convert into the concretized activity. So where concretization to abstractness, there should be a gradational and graded activities which leads to concrete thinking to abstract thinking. So encouraging mathematical exploration during the, promote, conjecturing and reasoning. And again, one more thing we can think about, create the process, not the product. Product is not important. The process where, how children, that's why we have, developed the formative tools. The true spirit of the formative tools is, for example, in our textbook, after simple explanation and discussion of a particular topic, immediately do these topics are there in our, Telangana and Andhra Pradesh textbooks. So the do this exercises is mainly intended to solve the problems by the students. So it gives whether the child is able to understand the above topic or not. So that gives the feedback to the teacher. So the diagnostic approach of identifying the students' weaknesses and strengths in the classroom is nothing but the formative assessment. So from that formative assessment and formal or informal assessment procedures, teachers should identify the strengths and weaknesses of the students. Like if you go to a doctor, what do? They do the CBP, complete blood picture. Then teacher should have the complete learning picture of the child of the particular class. So how they are responding, where they are lagging, where they are good, where they are doing mistakes. These kind of a learning picture should be there with the teacher. Then only you can start initiate the individualized teaching by giving a different kind of task and to the different kinds of levels of the teacher students. So this is the way. And conduct a math talks. This is very important. A small, for example, if I am teaching about their math talks, in the sense you can encourage the children in kind of role plays, storytelling, and a debate, and like that. For example, these kind of activities definitely open their mouth. They are supposed to encourage. So even here also we keep the bilingual approach or multilingual approach in the mathematical talk. So when you focus on the mathematical communication, for example, many children are failing, or we can unable to solve the word problems. What is the reason behind that? So for that we need mathematical communication. Children are unable to understand the mathematical terms which are given in the word problem. So they are very related to their close, real life problems, real life situations also, but they are unable to solve the problems of the word problems like this. So in such a way, so teacher has to rethink. So teacher has to provide such kind of environment in the classroom. So again, here the strategies of the teacher encourage creativity and multiple strategies. So, and again, expand the thinking beyond the problem and focus on the reasoning over the answers, and promote over reasoning and discourse. The discourse oriented pedagogy or classroom transaction definitely improves the democratic way of thinking. So, and last point I would like to conclude, there should be a from psychology side, building resilience and emotional regulation improves academic persistence. That is very important. Building, and again a cognitive side, students remember concept better than when they struggle. When they do with something, learning by doing, you improve. Learning by doing, and the perceptual learning. Here we can inculcate ELPS Kangai. EA means provide experience, such kind of experience, perceptual experience. When you provide perceptual experience, children are able to speak something about it. Then they speak, that is a language. When you convert the children language into mathematical language, and by doing and talking and listening, they develop a picture and they lead to the abstract symbol. So for this initiative, I hope the Santoshi ma'am, so really teachers regarding mathematics especially, we have to once again revisit the kind of parameter, what is the emotional intelligence among the how emotional intelligence among the mathematics teachers. And we can, for the curriculum design also, there as Rahel sir said, there should be a live discussion in the textbook writing and dialogues, There should be scope for the student talk also. There should be there in a group discussion. There should be a group activity should be there, and there how a group should present their group discussions. So in curriculum developing also we have to recommend such kind of things, and teacher trainings especially regarding the emotional intelligence and classroom management. How we develop the risk-taking culture, in the classroom transaction with respect to students and with respect to teacher. That is very important. And the true spirit of the formative assessment also there, and feedback for the growth. So these are all the recommendations we can give. We can train, and you can develop a kind of a model for the risk-taking procedures in the classroom. There you can implement in the classroom. So the classroom also, my favorite children could say, this is my favorite mistake. When I was doing problem, this is my favorite mistake. It was corrected by my teacher, and it was corrected by my friend. So that kind of, and mathematical journaling also encouraged in the classroom. So math circles or math clubs and that kind of mathematical activities. And one more thing, the ICT integration in the classroom transaction is very important for the more scope for the students' responses, students' participation. Here, we give a democratic classroom where that classroom is very noisy, children are asking questions. That is the risk-taking classroom. Yeah, when you allow the children, thought, respect the child thought process. So that is the channelizing the child thoughts is very important in the classroom. So this is the thing we have to encourage, our risk taking, sign of what encouraging the children, and encouraging the teacher should also change our attitudes from blackboard to backbone of the child. I can say, you are not a blackboard teacher or a digital board teacher. You are the backbone of the child. You are the supporter. You are the facilitator of the child. If you teaching mathematics is nothing, not solving the problem on the blackboard, making the child to think, making the child to take part in the problem solving. If your child is success in problem solving, then your mathematics teaching was done. So that is the way, make the child to think, make the child to respond, make the freedom, give the freedom of speaking in the classroom. And for that, teacher has to redesign his lesson plans, and teacher has to imbibe a different kind of innovative teaching learning strategies in the classroom transaction wherever it is necessary, and according nature of the keeping the nature of mathematics. So here maybe the different constraints and the opinions may come out. So syllabus, running after the syllabus, completion of the syllabus, there may be a different kind of constraints to the teacher of different managements also there. Even though when you allow the student to speak, to allow the student to know his mistakes and learning from mistakes, for that teacher has to design different kind of mathematical activities where child actively participates, where child can speak, where child can raise doubts, where child can where a child is unable to solve the problem for a particular juncture, their teacher has to identify. So these kind of culture could be inculcated in the mathematics classroom, for that teacher readiness, teacher planning, teacher ready to change, teacher adaptation in the classroom. So shifting from autonomy to democratic teaching strategies, so teacher centered teaching learning process to child centered and child oriented and child centered teaching, learning and assessment process should be encouraged in the classroom.
So sorry to interrupt. I think your time is up. If you don't mind, we can go with discussing and taking up questions, sir. Yeah. Thank you, sir, for that rich and practical talk. Your experience with curriculum development and ground level realities of math teaching adds a much needed dimension to our understanding of how instructional strategies can promote risk-taking and resilience among students. Now, before we open the floor to audience questions, I'd like to take this opportunity to engage our esteemed panel with a few key reflections which align with my ongoing research in this particular area. Now, for this, I invite Dr. Sirisha Ma'am, Research Cell Director, and Dr. Venugopal Rao Sir, Head Department of Genetics, St.Anne's College for Women, to take over the session. I invite Ma'am and Sir to kindly ask questions to our panelists.
Good
Sirisha
evening,
ma'am.
good evening, everyone. I thank the panelists for addressing such a problem. So I have my own doubts regarding the module development and other issues. First of all, I thank Dr. Sudhakar Garu for giving his insights about the psychological traits which has to be observed in the children. In this context, I would like to put a question to him. How the risk-taking behavior modify the child's behavior towards the positive output in the life. Can I speak to Dr. Sudhakar Garu? I want.
Yes, ma'am. Thank you very much, madam, for asking this question. It's not easy to answer this question, but I make an attempt. When children are pushed into some risk situation in mathematics classrooms, how best they can we can convert that particular situation into a positive, situation or positive behavioral situation. This is an important question which you have been asking me, and it all, to my knowledge, the fundamental idea here is that how child perceives the risk situation. What is his or her perception about the risk situation? There, actually, we need to explore. We need to understand, and if child can come out with, a comfortability, and also if he gets a democratic kind of situation where he can start dialoguing with other children and also with the teachers, and that kind of dialogic situation and imagination in the classroom situation might take the child to move into joyful steps in solving the problem. So it is very little complex also, madam. Your question is not that easy to answer. So that way, we need to, clinically, we need to understand first, what kind of idea a child has formed about the situation. What is his background knowledge? What are the assumptions of the child? What are the beliefs of the child about each and every word and concept, and the sentence, and also how the mathematical concepts are interlinked with regard to that particular problem. This need to be explored further, I think Divan sir can also answer this.
No, actually, I want to simplify the matter a bit. See, I think the problem, Sudhakar, is that as a teacher, we are not, clinical psychologists or even trained psychologists. So I think we have to use a more pragmatic approach. What I like about what you said in terms of the fact is that, we always think of risk-taking as a positive behavior. That's what we started by saying. But we also have to think about the fact that are these situations and the context that we are creating, are they conducive for the child to take risk and for the teacher to take risks, both? So if our assessment patterns, if our feedback patterns are such that they make the child defensive, they make the teacher defensive, then no amount of analysis is going to help you. So I think what I like what you said was pointing out the fact that risk taking is also a fearful and dangerous task. I think that has to be underscored. So we need to do that with empathy and courage, both for the child and for the teacher. And I think that's something which is significant. In that positive, some of the things which were said about the positive part of, so risk taking is positive only when it gets rewarded positively. So a child will have the courage to take risks only when he feels that he will be, he will not be chastised for it, he will not be punished for it, but he will be. So I think, rather than talk about, very difficult things which I think a teacher should do, but I think that's not something which is practical at the moment. All we can say is that if you can ensure that the teacher gives positive feedback to the child when he's taking a risk or she's taking a risk, that I think is good enough to me. Yeah.
Sir, I have a question. We basically happened to visit schools when we had assigned a very basic level of questionnaire, whether they like mathematics or no. It was probably majority of children, especially when they are in their higher grades, like 8th and 9th, they had shared with me saying that mathematics is something which we enjoy till our 7th and 8th. But then with the higher sections, the mathematics is becoming very difficult. We like the teacher, but we do not like the subject that she teaches. So probably we have developed that phobia towards mathematics, and due to which they do not want to basically opt or choose their career in that field. So what would you say regarding this, sir? I mean, how to curb this kind of situation?
Well, of course, everybody can have, see, two basic questions. First, when you say class 7th and 8th, they like mathematics. I don't know whether they like mathematics or they like the act of being able to get answers. Because if they were actually enjoying mathematics and doing mathematics, then at the level of class 9, the mathematics can not certainly become so difficult. But there are, there is a paper by Ramanujam, which is called, I will send that to you. It is called the points of transition. So he lists out places where mathematics there are transitions that happen in mathematics. From natural numbers, you go into fractional numbers and integers. From numbers, you go into alphabets, and so on. And then, as Sudhakar also pointed out, and so did the other people, that algebra and geometry get interlinked. Now, if you read them as pieces separately, and you don't have a language and vocabulary for reading mathematics, then I think somebody in the remarks also said, mathematics is disconnected. So as long as mathematics remains disconnected pieces in our minds as different elements of chapters or areas, you are not actually comfortable. So I think students are justified in saying that mathematics become difficult. And, the materials that we create are also dense. In fact, the NCF 2023 has said teaching less in teaching more. And they have said that, the textbook should not be completed. So, of course, Krishna Kumar also used to say that textbook has to be covered, not uncovered. It doesn't have to be covered, it has to be uncovered. So the point, I think, in my mind is that if mathematics is taught as something the child has to do, which also was said by many people, and if the child is doing mathematics, and doing mathematics means not doing it as a calculator, but doing it as a person who is going to be a mathematician, then you will not get afraid of mathematics ever. You may not be able to do some problems. That is not important. I can't do many problems. We can't solve all problems Professor Sudhakar is saying repeatedly that I don't know. So he's a psychologist. He can say that I don't know. I can try and answer. So similarly, in mathematics, you can say that. But somehow, we don't allow ourselves to make the statement, I don't know, but I can try. And I think till that is accepted in the system, the teachers and children are going to have a very, very difficult time taking risks of any kind. Sorry.
There's Murthy from SRP who would like to, from the participants' end, who would like to ask questions. Murthy, sir, you can unmute yourself. You can ask your question.
So good morning, ma'am.
Good
So
evening.
presently I'm in USA.
Okay, sir.
I'm very happy to, and I thank you to arranging this such a wonderful program to
Thank
meet
you,
a great stalwarts like our Guru Sudhakar sir is the Guru mine while I was studying in Bachelor of Education Usmania University.
Okay.
And also I would like to say thank to even Padi sir, Rahil sir, and my colleague Dr. Ramesh sir. So my question is to our Guru Professor Sudhakar sir. How can we adopt our teaching methods to be more inclusive of students with different learning styles or emotional needs in maths? So that's my question, sir. After a long time, I'm hearing your lecture, sir. I'm very happy to be. I'm excited.
It's not a lecture, sir. Just observations I made.
No, sir. No, sir. No, sir. I'm recollecting those days.
Okay, thank you. Thank you very much. Thank you very much. I'm happy to know that you are in US and you are attending this program. And your question is very broad question, sir. Very broad question. And right now, you know, the Dr. Ramegar also has given so many ideas, so many strategies he has floated, and to make teaching the pedagogical practices aligning with the children's child's psychology and development. We need to adopt multiple strategies, and we have been learning from Professor Diwan also that we should not stop child to think, and there are multiple answers, multiple paths to reach, that kind of encouraging that kind of multiplicity and constructing multiple worlds within the classroom situations. I think that we need to encourage, But generally what we do is we try to impose certain way of doing mathematics.
Yes.
So that is wrong. So that's why Ramegaro has identified so many strategies, and he could enlighten us with lots of details. And I think Murthy, I cannot answer the complete your question, but this is one.
Murthy sir is a resource person for the SCRT sir. He is also doing developing the curricular activities and modules teacher training. So he's also eminent mathematics teacher.
Oh.
But out of interest, I think the same thing about the where you give a chance and the child should feel freedom. My teacher can allow me. That's enough. My teacher gives me a lot of strength. When I could do mistake also, he gives me a boost. That mistake may again can't made me to do mistake. So that kind of mindset, if a teacher could have, definitely the classroom may flourish. It takes time, sir. One day we cannot change all the entire scenario, but the practice of the teacher, the classroom situation, and the student teacher relation regarding. So if a mathematics teacher comes in olden days, what we do, our teacher will beat. So he simply copies something and he will bring it out. Nowadays it has been changed. The whole scenario has been changed, so that they are getting answer from anywhere. Now the AI is there, they are getting answer, but getting answer. But make the child to think, and that is very important. It is a kind of a eagle eye vision of the teacher regarding the students particular learning styles. For example, he is very good at mathematics. He is inclined to learn a different kind of problem. If Murthy sir is doing the same thing, so he is identifying the talented students. He is nurturing the talents of the students. So that is called individualized. Very low student is there. So focus on the prerequisites, focus on the very basic mathematical operations. So from there we have to kindly bring in the mainstreaming. So it's a kind of very that is why sir said the risk taking of the teacher is very important in the classroom.
When are you coming back, sir, Murthy sir? Murthy garu, when are you coming back to India?
You
Santosh
are
is
unmuted.
unmute, Murthy. He's unable to unmute, I think.
Okay.
1 minute. 1 minute.
Yeah.
Yes, sir.
Excuse me, I would like to add one thing.
Sir.
Here, we should encourage the child to talk something. Okay, for everything, what is his perception? Okay, because of our stimulus, our presentation of stimulus, the child will perceive. Okay, that may have verbatim. Okay, which is in the memory bag of the child, or just as our beloved Sudhakar sir told, that the gist memory will give do not have proper verbatim. That's the reason the child cannot express bhava, bhasha, idea and language.
Yes.
Some we will have some idea, but not for that appropriate language may not be there. Okay, so that through that verbatim we can understand the child's actually what happened within that. Okay, teacher can translate that into major premises and premises, minor premises as logic. Okay, logic always will be on the major premises, minor premises we will add. Then the floating of that each reason why how that minor premises is made from the major premises. If the teacher understand this, he can explain, oh, because of you thought this, you are talking about this, your perception is this. If this connection, if teacher teaches the child, okay, child will understand, oh, this is my logic, and then he will add some more minor premises and he will reach some conclusion, and that may be correct answer, that may be wrong answer, but child, okay, will get some idea of the logic, the development of the problem, the answer or logic. Okay, that's my idea. Okay, please, thank you.
So thank you for all your sir. Thank you for all insights given me, the boost up, and also that can be implemented on our classroom. So thank you, sir. Thank you, Anand. Sir. Thank you for giving me this wonderful opportunity to Santosh Shukla ma'am, and namaskars to my all gurus. Thank you, sir. Thank you.
Thank you, sir. We are also fortunate that we have an international participant in our panel discussion. Thank you very much for joining us, sir. So we have AC V Prakash, sir, from the audiences who has raised his hand. So Prakash, sir, you can unmute and you can ask question to our panelists.
Thank you so much, ma'am. Very good evening all. And I am very fortunate to have such a scholars and great personalities over here. And this is a great platform like me who is interested in teaching mathematics, and it empowers now with all your suggestions. I can make a little bit better in my teaching career. And one clear doubt I have here is the first one is when introducing the number system, I have followed all the naturals and wholes is okay. That what I have gone with the discussion. And rational numbers, when I start with the rational numbers, that 1 by 2, 1 by 3, nowadays, when I asked the students, they told that we didn't see those. So that I have converted into decimals, and you can see in your petrol bunks and weighing machines. I got that, okay, the decimal form of a rational number introduced by me are very the students accurately they found that the rational numbers are visible in the real life, but I'm unable to explain the irrational numbers which are there in the real life. That may be the one task I have faced in the school education, the students those who are asking the doubts. And the second one is if these personalities, these great personalities all over there in AP and Telangana, not only that in total national level, can't we have a maths general to the school students as an initiative maths general, maybe the things that you have done the mistakes, they can do the mistakes. The sir has explained me how the 2 twos are 11 is a is it's not a wrong answer, it's when compared to the base system. So if we have any general like that, if you can create that to school students, maybe that risk they can take with the help of some examples, I think. Thank you, sir.
Okay, So for this, what I think is, so textbook may not solve all these kind of problems. So parallel non-detailed textbooks like that, we have to produce, or SCRT or NCRT has to produce, like Infinity series of Russia. Okay, so they have taken very small concept. Okay, as you said, rational number, irrational number, how many types of irrationals are there? Okay, like that whole within 100 pages, 150 pages, the small booklet will be there. So from class 1 to, from basics to a little bit degree level, they prepare the document and they keep ready-made. Okay, like that, American Mathematical Association also developed so many that supporting textbooks are developed. But unfortunately, in India, they develop guides, okay, just for marks and like that, but do not take the interest on preparing that. So these reference books or these general parallel books will help the children to understand more and more, and they will bring on pi value. How, what is the value of the pi? Even we say 22 by 7. 22 by 7 is gives 3.142857, but actual pi is 3.1415. Okay, so here actually we are doing wrong interpretation. We do not tell how is, what is the story of the pi. Okay, how this number of unlimited numbers are coming. Okay, as you said, irrational numbers. For irrational numbers, a number of terms will come. How much we calculate, so many numbers will come. Till now, a very big book. If you go to Usmania Library, that was published in 1965, there is a book on pi value only. It starts with 3.1415, like that. First page, second page, 1,000 pages they printed. The very big book, and last page they said it's continuously it is calculating and so many digits are there. So we will publish later one more book. So this kind of things are there in mathematics. As Divan sir said, and Sudhakar sir said, a doctorate in mathematics may not solve a simplest problem of class 6 arithmetic. But in other subjects, it may not be like that. In history, okay, if you studying that PG, so easily they can talk about class 6, class 7, so studies as science, even science subjects also. Here, because this independency is also there, accuracy is also a big problem. And what the syllabus is there in the degree may not be directly interrelated with class 6, class 7. But we have to, as a teacher, for example, if you take a rational number, okay, there are in degree, if you read reducible, irreducible, okay, like that, those terms are there. Those terms are easily in easy language we have kept here. Okay, so that kind of connection the teacher has to make, and that he has to, okay, as Sudhakar sir said, still now I'm reading the books. Like that, the teacher should be, okay, continuous reader, continuous. For that, no salary or nothing will be, okay, equivalent will be there. So that kind of thing will do. So many parallel books need to be published and need to be written. Thank you.
Sir, I think it's time that we conclude the session now, because it's already 2 hours past. So maybe we can have some more further discussions near future. Venugopal Rao sir, would you like to ask any questions?
Yeah,
So you
Pavan.
can-
Pavan Kumar. Yes, Pavan, you can ask.
Okay, Pavan.
Yeah, Nalla Pavan Kumar.
Yeah.
Hello. I'm Venugopal. Hello.
Yes, sir. Yes, sir. We can hear you.
Yeah. See, there are some suggestions to make and also some questions. Actually, I started my career after the SSC. I wanted to take mathematics, but at the time I was afraid. I don't know why I was afraid. Then I took BPC, then BSc, MSc. But when I did PhD, lot of biostatistics, mathematics I had to learn. Then I repented that I have lost my bus. So in such cases, how to identify children who are really having this potential. But now, as a geneticist, we are coming out with genetic potential where some DNA is responsible for logical reasoning, mathematical abilities, and all. If that is the case, in future, the technology may come up where we can categorize the class into more genetic potential, average potential, low potential, and encourage peer learning among the students. This was my query. So, can you really throw some light on this, sir? Are there any studies in this direction? Anybody has done any research in this direction? Like,
No, I don't know. I'm not aware. I don't think anybody is aware of any researchers. But I think the general point that one of the points about mathematics is that whenever you need mathematics and you approach it with fear, I think what Professor Venugopal, what he said, shows that you can learn. And that could be at any stage. It's not that you have to learn mathematics only at a certain stage. The second point, I think, is also about it. What his fear is about what we look at as class 10 at that time, SSC mathematics. So the nature of mathematics that we present to the child also makes the learner scared. But I don't know whether there are any researches to kind of respond to the question that he's asking.
Pawan Kumar, I think you can ask your question.
Thank you, madam. Good evening to all. I'm audible, madam?
Yeah, okay.
You are audible, sir.
Good evening to all the panelists and participants. Sir, when we have, as a teacher, as a math teacher, when we have working on a different mathematics problem in the classroom, we have some aspects. Some are helpful to us, some are not helpful. Some helpful items are thinking time, working with partner learning or collaborate learning, taking time. These are helpful to the teacher or students. Some are not helpful. When we're dealing with the mathematical problem, someone shouts it is easy, or someone give it a glance the answer. Someone asks telling me how to solve the problem. How can I handle all these situations within the period, within a time limit, within the 45 minutes? That is my query, madam.
Yeah, Pawan, it is very good question. It's a practical question where a practical teacher faces. Because you are a risk-taking teacher, I feel. Where a risk-taking teacher is there, he faces a problem. That is the big issue. Even though it is all the your time management. So you have to first of all, before teaching any for example, if you are taking a particular class, particular topic, let us diagnose the levels of the children to particular concept. So just now I repeated. For example, if you are teaching similar triangles in the 10th class, so first of all you have to identify how many students in your class, how many students are able to they are very good at the prerequisites. That means the previous concept which they have learned. If they are having the prerequisites, then your strategy will be different. So definitely the levels of students will be varying in every classroom, but you have to plan how the different first conceptual understanding, activities for conceptual understanding, activities for reinforcing the concept, Then you try to give a problem solving, model problem solving by the teacher. And then after, give individual problem, a small problem, that is a kind of program learn, teach less and give much practice. Definitely it takes time. But if you address all the levels of the children, it is very essential for the individual attention of the teacher. That means individualized instruction is very important. When a small concept is transacted in the classroom, most of the people are doing the problems, but very less students are not able to even attempting the problem. That is the big issue. So what go and touch the child, you can touch their arm. What is your problem, where you are stucking? When you start analyzing, talking with the child with a true heart, definitely they will open the ear. So there you start with the where they are lagging, then you fill the some prerequisites, then let them mainstream to the conceptual understanding, then leads to problem solving. When they are able to solve problems in problem solving also, for example, very low student is there, give a similar problems, then change the form of the problem, then let them lead to the different kind of problem, different solvers of the different kind of problems. So that is very difficult and that is very time taking, if that is the concern of the teacher. So every child is, if you feel every child is important in my classroom, definitely a teacher has to take a risk. That is very important. So when that, for that, teacher should have patience, a proper planning and proper execution in the classroom. That definitely in a due course, it address the every problems of the every child. Every child is moving towards the mainstreaming of the learning outcome. That is my concern. So for that, you need mathematical resources. You need some worksheets. You need some program learning worksheets. Some concept will be there, simple concept, and a simple problems. Then gradational problems, different kind of problems leads to different higher level problem. So that kind of planning of a teacher. So once a teacher plans, one single planning is nothing but 100 years of planning or 100 kinds of planning, because it addresses the different kind of the levels of the children. So that is very important, my dear Pawan. So he's my classmate and is my we childhood classmate. Thank you, Pawan. I think I
Thank you, sir.
tried to address your question.
Thank you, sir. I think this would be the last question from the participants that we will be taking, because we are running short of time. Ms. Varnalata, I think you can ask your query. You can unmute yourself and you can ask.
Yeah, ma'am. Thank you, ma'am. I'm Advil, ma'am.
Yes, you are audible.
So, good evening to all, sirs. It is a very great opportunity to me to participate in this panel discussion. So, what my doubt is, I'm handling with the 6th class maths children. So from last 2 years, I am creating some stories and some games to make it easy to understand the children that difficult concepts in maths like LCM, HCF, like this. So what happening? My problem is nowadays children are focusing only on that story or on that game, and they're not concentrating on the actual concept. So my doubt is how to overcome this problem. Is there any way to overcome this problem? So please let me know how to overcome this problem. Thank you.
See, there are two questions which Pawan had asked as Swarna. See, classroom problems, specific situations, we can give very general advice, and that general advice is already available to most of us. The point is that what we do in a specific situation is something that only you can decide. We know that children are at different levels, so how to deal with them, it will always remain your ability to actually ensure that you are able to give kind of tasks which children can do at a different pace. Similarly, when you talk about games and stories, there is a difference in the way you perceive the story and the game than the child perceives. So you have to have the patience and the confidence that it will take time. And you cannot expect that you have told the story And because you've told the story, they should get the same thing out. I mean, the problem with most of us in mathematics classrooms is that we think our explanations and our way of looking at things is the one that has to be given to the student. That doesn't help.
Yes, sir.
And the important thing is to give them patience. And I mean, everybody has said that, Sudhakar, Ralu, Ramaya, they have all said that give the child space to talk. And I think you tell the story, then that, ask questions which are open-ended, which are leading, and that student will start making connections. We have to allow the child to make connections from the games and the stories to the concepts that are underlying them. It's not so straightforward for them.
Yes, sir. Thank you very much.
Aligning the stories, puzzles to the main concept, and in a due course, giving a guided practice. So that is very important, as the sir said.
Okay, sir. Thank you very much.
So I think it's time for us to conclude, sir. As we conclude this intellectually engaging and forward-thinking panel discussion, I feel deeply honored to be a part of such a meaningful academic exchange. On behalf of St. Anne's College for Women, Hyderabad, I extend my heartfelt gratitude to our distinguished panelists for their illuminating contributions. Professor Hridayakant Diwanji, educationist and researcher, Setu Initiatives, Udaipur. Professor V. Sudhakarji, Chair Professor of Education, Chanakya University, Bengaluru. Dr. Kandala Ramayaji, School Assistant in Mathematics, ZPHS, Abapur, Telangana. Mr. K.V. Rayaluji, former faculty, Government, IASE, and guest faculty, GIASE, Hyderabad. Your insights on cognitive freedom, psychological safety, and pedagogical transformation have added tremendous depth to our understanding of what it means to teach and to teach with courage. I would also like to extend heartfelt thanks to each of our participants who joined us today, representing diverse educational backgrounds. The response to this panel discussion has been truly humbling. Your active presence reaffirms that the movement to make education more human, fearless, and transformative is not only timely, but deeply shared. Special thanks to our dear principal, Dr. Sister A. Vijarani, and college management, the research cell, the ICT support team, Ms. Rajeshwari, and my students, Ms. Ankita and Ms. Kulsum, for their seamless coordination. Education is not about feeding students with the right answers. It's about giving them courage to ask bold questions and keep asking. And I think this is what our panelists have discussed and emphasized on it today. Let us return to our classrooms, our institutions, and our roles, not just with renewed strategies, but with a renewed philosophy. That mathematics is not just a subject, it's a journey. And every learner deserves the safety to stumble, to wonder, and to rise again. And with that aspiration, I close with a timeless blessing from the Rig Veda. Ano bhadraha kratavo yantu vishwataha. May noble ideas reach us from all sides as we continue building classrooms where courage is valued more than correctness. Thank you once again, wishing you all continued success in your noble journeys as educators and leaders. God bless you all. Namaskar. I request the participants to kindly fill out the feedback form, which is shared in the chat box. Your reflections will guide us in curating future academic engagements. Once again, request the participants to kindly fill out the feedback form, which is shared in the chat box. We will be keeping the responses open for filling the feedback form till tonight. Thank you so much. God bless you all. Thank you, sirs. Thank you once again for joining us today.
Thank you. Thank you, ma'am.